Good morning, everyone. My name is Hameeda Noitabtim. I'm a medical student from Burapha University, Thailand. Today, I'd like to present our research name, Investigation the Impact of Celastrus paniculatus seed extract on mitochondrial dynamic and neuroprotection in an MPP plus induced Parkinson disease model. So, Parkinson disease is a neurodegenerative disorder characterized by progressive loss of dopaminergic neuron in substantia nigra, with mitochondrial dysfunction playing an important role of neuronal apoptosis. Recent investigation indicate that Celastrus paniculatus may have an anti-apoptotic property in Parkinson disease model. However, the precise mechanism underlying the effect of Celastrus paniculatus on the apoptotic pathway have yet to be elucidated. And for this research, we studied Parkinson disease model from SHSY5Y cells. These cells are well suited to study neurobiology and pharmacology related to dopaminergic therapy due to the ability to synthesize dopamine and noradrenaline. With this background in mind, our objective is to investigate the mechanism of Celastrus paniculatus seed extract on mitochondrial membrane potential in an MPP plus induced Parkinson disease model. To achieve our objective, we began by culturing cells in medium consisting of a 1-to-1 mixture of modified eco medium and HAMF12 supplemented with 10% fetal bovine serum under condition of 37 degrees Celsius in 5% carbon dioxide. The medium was changed every 3 to 4 days with subculturing technique until day confluency. And as you can see on your top left of the screen that there are stages of cell growing in cell culturing flask. Once the cells were ready, they were plated into 48 well plate at a density of 60,000 cells per well. Then we added methylphenylpyridinium or MPP plus to induce neurotoxicity. 2.5 hours later, we added the aqueous soluble fraction of Celastrus paniculatus seed extract or CPSE in different concentrations. The concentrations were 1, 50, 100, and 200 microgram per milliliter. Lastly, after 3 hours, we added JC1 immunoassay to evaluate function of mitochondrial membrane potential using fluorescent microped reader. The value of rate to gain fluorescent intensity ratios from microped reader indicating function of mitochondrial membrane potential was statistically analyzed using one-way ANOVA and Dookie post-hoc tests to identify the differences between groups. For the result, the bar graph showed that group treated with 1 microgram per milliliter of CPSE had a significantly higher rate to gain fluorescent intensity ratio compared to the control group, indicating an improvement of mitochondrial membrane potential function. In contrast, group treated with higher concentrations, or you can see the 4th, 5th, and 6th bars, show significantly lower rate to gain fluorescent intensity ratio, indicating a reduction of mitochondrial membrane potential function. From this finding, we may conclude that optimal dose of CPSE enhance mitochondrial integrity and provide neuroprotection effect, while excessively high doses lead to neurotoxicity. With this being said, our research answered the hypothesis that Celastrus paniculatus affect mitochondrial membrane potential on neuronal apoptotic pathway. Therefore, future research can focus on investigate the safe use and assess the rate of excessive use because these could help to develop mitochondria-targeted drugs for neuroprotections in neurodegenerative diseases. Thank you for your attention and welcome for any questions you may have. Thank you.
Such an impressive work. Do you have any comments or any questions?
So that's an interesting test. So my question is to confirm the effect of this agent with the uh, the current therapeutic use that we have nowadays. So, do you have any idea to compare with the drug that we use as the anti-Parkinsonism?
So from what I understand is that the drugs for Parkinson disease in nowadays it cannot be cure the disease, but it's just for relieve the symptom. So like levodopa, which is the agonist drug that kind of adding releasing of dopamine, but for this mechanism of drug, it will like cure the mitochondrial function, which is the main cause, and can be cure the diseases, not just relieve the symptom. Yes.
So, to confirm your idea, do
To
you think
confirm.
can we use another cells to confirm the mechanism of this agent? You said this agent protects the cell from the different mechanism than the levodopa, as you
Yes.
said, right? Therefore, to make the cell survive, this agent use the different mechanism, right?
Yeah.
So therefore, this agent should have the same mechanism with the other. Is that correct?
Could you repeat the question again, please?
I mean, it doesn't matter what kind of cell you use, because this agent already save the survival rate of the cell, right? If you said it different mechanism from the levodopa,
Yeah.
right? So to confirm your idea that you said, as you mentioned, you said it's use different mechanism, right? Therefore, can we change using another cell?
Well, this is the specific. You mean the SHY5Y cell?
Yep.
This is like a specific cell that's for study Parkinson disease model, because from previous study there are a lot of researchers that they use the type of cell to study Parkinson disease, and then when we add that like the methyl for phenylpyridinium or MPP plus, which is like a neurotoxic substance that affects only like selectively uptake on dopamine neuron, which is and finally it leads to mitochondrial dysfunction. So this is like the specific cell to study Parkinson disease.
Any suggestion for the further experiment?
So for further experiment, from what we study, it's the concentration of CPSE is pretty wide. So for further experiment, we might like narrow down the concentrations of CPSE, so we could like know what like the most effectiveness dose that could help or like enhance mitochondrial membrane potential function.
Thank you very much.